Hello and welcome to another Haas Tip of the Day. Now, all of the prototype machinists out there should get something out of today's tip. We're going to show you how you can use your machine to draw your clamp positions and features right onto your parts. Now, I've loaded up a part onto my mill. I've got to get two of these flanges out the door, but I don't want to spend the time or the money to build a custom fixture for this one-time job. So here's what we're going to do. We're going to draw our part features and our clamp positions right onto the part, not by hand. We're going to have the machine do it. By doing that, we'll be able to perfectly place our clamps on our part, which will help us avoid making that fixture we talked about. Now, we can just chuck up a marker into our spindle, but then we'd have to get our Z depths just perfect. Too deep and we crush the tip on our marker. Too shallow and we can't see the writing at all. What we really need is a spring-loaded holder for our pen. Now, you can buy these online, but we're going to show you how to make one with just a few pieces from your local hardware store. Now, what we'll need is a 3-inch piece of 1/2-inch PVC pipe, a 1/2-inch male adapter, a 1/2-inch cap, a permanent marker, and a balloon. This kind of balloon. Now, I bought a whole bag of these at the local dollar store for $1. Okay, for assembly, we start off by cutting a 3-inch piece of this 1/2-inch PVC pipe. Then we take our balloon and just wrap it around the end of that pipe. You can already see when we put our pen in that we've got our spring action. At this point, we just wet our whistle and pretend like we're licking a stamp. We want to lubricate the edge of this balloon before we press on our adapter. Now, go ahead and press this on as hard as you can. Make sure it's well seated. Now, we just load up our pen and screw on our cap. But there's no hole in our cap yet. Okay, what size hole do we make? This is pretty easy to find out. We just grab a set of calipers, measure the shoulder on our pen, and drill a hole in that cap about 5 or 10 thousandths of an inch larger than the shoulder on the pen. We want a nice, comfortable slip fit. So I took our caps, I loaded them into a vise, I probed them, and then drilled a hole. Now, be careful not to use a drill that's too large. If you make the hole too big, when we put our pen in there, it's going to wobble pretty bad, and that's going to give us terrible lines on our parts. We want a nice, comfortable slip fit. Also, be careful when deburring these caps for the same reason. We don't want our pens to wobble. We want nice, clean lines. Well, we're all set. All we've got to do now is drop in our marker, take that cap that we just finished machining, and screw it on. We now have a fully assembled, spring-loaded part marker. Let's load this up into a holder. Now, the next question is, what RPM do we run this tool at? This holder comes out of the box rated for 25,000 RPMs. Our pen is rated by the factory at 0 RPMs. 0 RPMs. Now, you can double that if you're just drawing on aluminum, or even triple that number if you're drawing on plastic. Okay, so you've got it. M05, 0 RPMs. Now, our part's ready to go. I've already written a program that's going to draw on our features and our clamps. I've gone ahead and probed our part. So now all we've got to do is load up our pen, close the doors, and press cycle start. Okay, so I already touched off my pen right on top of my part, just like I would any other tool. Now I'm going Z minus 35 thousandths of an inch. I've got a 1/4 inch clearance plane, and I'm feeding at 200 inches per minute. Now, our depth really isn't too critical, because with this spring-loaded pen holder, we're going to get a nice even line, even on uneven surfaces. This same technique can be used on our live tooling lathes as well. For a large part, I like using the permanent marker. If it was a smaller part, I would probably just print out my drawing at 1:1 and take that sheet of paper and lay it on top of my part for perfect clamp placement. Our part looks great. I can now place my clamps exactly where they need to be without worrying about those counterbore holes. Now our pin adapter is made out of 1/2-inch PVC piping. The OD on that is 0.84 inches. If you don't have a collet big enough for that or an end mill holder that size, that's not a problem. You can make this same adapter out of EMT conduit, the metal conduit. We're going to build it the exact same way. Take a 3-inch piece of EMT, use a 1/2-inch male adapter. You're going to load the balloon down the middle the same way we did with the PVC model. Then you're going to make the same exact 1/2-inch PVC cap. This will mount right onto that adapter. The only thing you want to do different about this compared to the PVC is that you really have to be careful to deburr the ID and the OD so it doesn't pinch that balloon as you put the adapter on. Well, hopefully this tip is going to save you some time and some effort someday. Now, for a bill of materials for the parts that we use for today's video, click on the bonus content at the end of this video. While you're there, be sure to subscribe to this YouTube channel so you don't miss any upcoming videos. That's it, and thanks for watching this Haas Tip of the Day.